A step function is a function that uses pieces, that uses parts of multiple functions to represent one new function. In this example, we have the function f, and it's of the variable x, and it's equal to, with a big bracket, all of these functions. And all of these if statements tell me which x values will determine which function I'm going to use. If I look at the first function, f of x equals -3. F of x equals -3 is really y equals -3. And if I look at the equation y equals -3, I really have a horizontal line. So I want to graph the equation y equals -3. So I'm going to go 3 on the y-axis, and I'm going to connect all of the values where y equals -3, which gives me this horizontal line. Now these if statements tell me which x values I want to use for this line. I want all the x values where x is greater than or equal to -7, but less than -3. So I'm going to go in the x direction, -7. And when I go in the x direction to -7, I want to be on this line. Well, this line is right here. So I'm going to put a closed dot on the line where x equals -7. Because of this equal sign, or equal to, I want to put a closed dot there. And at -3, I want to put an open dot on the line. Now this tells me I want to be on this line if x is between -7, including -7, and -3. So if I look at this graph, I don't want any of these values that are outside this little window. So I'm going to erase all of those values, and I'm only going to connect the x values between these 2 points. So when x is between -7 and -3, my output is -3. I'm going to do the same thing for f of x equaling 5. If f of x equals 5, y equals 5, and I have a horizontal line. But I don't want this entire horizontal line. I only want this horizontal line when x is between -3, including -3, and 1. So I'm going to go in the x direction to -3, and I'm going to output 5. And I'm going to put a solid dot at 5, because, excuse me, -3 in the x direction at 5, because I want to include -3. And I'm going to put an open dot at 1. And I'm going to erase all my other values and only connect between those 2 points. So when x is between -3 and 1, my output is 5. It's on this horizontal line. When f of x equals 7, again I have a horizontal line. But I only want to include the points when x is between 1, including 1, and 5. So I'm going to go to the right 1, and I'm going to output 7. I want to be on this line when x equals 1. And when x equals 5, I'm going to put a open dot on this line. And I'm going to erase all the other points, and I only want this portion of this line when x is between 1 and 5, including 1. And finally, my last equation is f of x equals 9, or f of x equal, or y equals 9. So I have a horizontal line, and I want this horizontal line when x is between 5 and 9. So I'm going to go in the x direction, 5, and I'm going to output 9. And I'm going to go in the x direction, 9, and I'm going to output 9, but I'm just going to put an open dot there. And I only want to connect the values between. So if I look at my graph, I do have a function. If I go from left to right, I always pass the vertical line test. If you look at this point right here, when x equals 1, 2, negative 3, I pass the vertical line test because I have a solid dot here and an open dot here. So when x equals negative 3, I'm right here. If x was just smaller than negative 3, like negative 3.1, I'm down here. If x is bigger than negative 3, like negative 2.9, I'm here. My graph should line up with what my function says. If I want to evaluate the function at f of x equals negative 3, I'm going to input negative 3 in for my x value, and I'm going to output where I am at the graph. So if I input negative 3, my output is 5. If I look at my numbers, that makes sense. Because if I look at this x value, negative 3 fits in this interval, which means my output is 5. If I want to evaluate when x is 1.5, I'm going to go in the x direction, 1.5. And my output would be here. So my output when x is 1.5, my output is 7. Which makes sense. If I go into this interval, 1.5 fits between 1 and 5, so my output would be 7. My graph and my function notation should line up. Notice that I only have one answer for when x equals negative 3. I only have one answer for when x equals 1.5. Again, it's a function, so I should only have one output for all of these. I don't need to plug in negative 3 to all of these equations, just to where it fits. The other thing I want to point out is if I read this graph from left to right, it's continuous. If I start from left to right, I'm on this line, and then I immediately hop up here, and then once I hit 1, I immediately hop up to the next line, and then once I hit this value, 5, I hop up to this line. So even though top to bottom my graph is not continuous, left to right my graph is continuous.